Welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar. I am an assistant professor in IT department. Today I am going to talk to you regarding DDA algorithm, which is a part of Computer Graphics and Application course SYIT semester 4. Under this, what are the things we are going to cover are as follows. What is a line and segment? What is the equation of line? What is the slope of line? Examples of drawing lines, and then DDA algorithm. So before we actually start with the DDA algorithm, we should understand what is meant by a line, what is meant by a segment, then what are the equations of the line, what is the slope of the line, and we will see some drawing line, line drawing examples. So let's start with what is a line and a segment. So here in the diagram you can see a black color line. So this line is extending up to infinity, and of this line we are using particular 2 points to define a segment. So you can see the point 34 and 96. So the part in between that point is a segment. So we can say that a segment is a part of a line. It is enclosed within start and end point. One more thing that we have to understand over here. So whatever segments we see over here is made up of small points. Okay. So when we want to draw this segment graphically, we are actually plotting one point, and that group of point will going to represent that segment. So if you check between the start and end point, I have showed you many small points. So including all these points, you can have that complete segment. I have shown you with the bigger dots. Actually these dots are very small. These points are very small when you plot. So suppose this segment is there, then 200-300 points will plot in between that start and end points. The end point, we will start with the example over here. So the endpoints of a line 0, 0 and 6, 12. We have to compute each value of y x steps from 0 to 6 and plot the result. If you check now, so there is point 0, 0 and point 6, 12. If we want to find out the points in between, we are going to plot that small point which are there in between these 2 points, and at the end we will get the complete segment. I will elaborate this example afterwards. Let's proceed further first. So after understanding what is a line and segment, we will try to understand what is a line equation. Here you can see I have written y is equal to mx plus c. This is called as a line equation. In this equation, the m is the slope of the line and c is the y-intercept. So if you check, if I extend that segment 3, 4, that line will going to bisect your y-axis at 3. This line intersecting, that y-intercept is called as a c. In this line equation, y is equal to mx plus c, m is the slope and c is the y-intercept. So in this diagram you can see for this line the y-intercept is 3. Now we will see what is the slope of the line. We have seen the equation y is equal to mx plus c. In that m is the slope. So how we are going to find out that m? Initially we start with the line segment. So line segment is having a start point and end point. We should have that, always we have the coordinates of that start and end. So here if you check, the start point is 3, 4 and end point is 9, 6. So we have that 2 coordinates. Using that coordinates, we can find out the slope. So let's see, let's say that 3, 4 as consider that 3, 4 as x1 and y1, and 9, 6 we will consider as x2 and y2. 3, 4 as x1 and y1, that is x1 is 3, y1 is 4, and x2 and y2 as 9 and 6, that x2 is 9 and y2 as 6. So how we are going to find out the slope then? Slope m is equal to y2 minus y1 divided by x2 minus x1. So in this example, our y2 is 6 and y1 is 4. So 6 minus 4 is 2, and x2 is 9 and x1 is 3. So 9 minus 3 is 6. So the actual slope is 2 by 6, that is 1 upon 3. This way you are going to calculate the slope of a line if we have that start and end point coordinates. Once we understand the slope, here I have showed the things, that is what is that distance. So if you check, I calculated y2 minus y1, that is 6 minus 4. So that you can see on the y-axis, that distance is 2, and on the x-axis you can see 9 minus 3, that is 6. So that distance is 6. That green color I have showed, so that distance is actually 6. So with the projections I have shown on x and y axis, actually that are the difference, that green color is the difference between the coordinates. Now we will see this example which we left earlier. See over here. So now it will be easy for you to understand. So start point is 0, 0 and end point is 6, 12. So slope m is y2 minus y1 upon x2 minus x1, that is 12 minus 0 and 6 minus 0, that is 2. Okay. So for the same line, now we will try to find out c. Okay. So the easiest way is one coordinate, that is our start point is 0, 0. Na? So that values we will put in that equation. Equation is y is equal to, now m we calculated as 2. So now our new equation is y is equal to 2x plus c. Now y and x value we can either put 0, 0 or 6, 12. So now I am putting 0, 0. If I put 0, 0, then obviously the value of the c is 0. So final equation what I am getting, y is equal to 2x. So this is the final equation which we get after putting the values of x and m, c and m. Let's see it again. See our initial values, that is x1 and y1 are 0, 0 and x2 and y2 are 6, 12. So what is the slope? y2 minus y1 upon x2 minus x1. So our slope is coming 2. So that value of 2 we are going to put in the equation. The equation value now will become y is equal to 2x plus c. Now this c is the x in y intercept. So again what we will do, we will put the value for x and y. So as per see, it's initially it is written na, ki our start point is 0, 0 and end point is 6, 12. So any even values we can use. So I am using over here 0, 0. So if I put x is equal to 0 and y is equal to 0, then I will get c also equals to 0. Now if I put this c value and m value in my original equation, what I get, y is equal to 2x plus 0, that is y is equal to 2x. Now using this equation I can find out the different points on that line. Suppose I consider x as 1, then obviously my y is 2. So that point is on my line. If I consider x is equal to 5, then y is 10. So that point lies on my line. So this way I can find out different points which are lying on the line if I can able to find out the slope m and the y intercept c. With the help of that M and C, I can find out different points on my line. We have gone through this slide, so I'm just moving ahead. Okay. Now we will see what is a line drawing algorithm. A line segment in a computer graphic is a portion of a straight line that extends indefinitely in position in opposite direction. So I have a line, okay, and it is extending indefinitely in opposite direction. In both the direction it is extending. If I took a portion of that line, any portion with a start point and the end point, then it is called as a segment. It is defined by its two endpoints. Its density should be independent of line length. The slope intercept equation for a line, so this is the equation for the line which we will use, y is equal to mx plus c. In that, m is equal to slope of the line and c is the y-intercept of the line. These are the important points whatever we studied up till now. Now again we will see one more example like earlier only. So we have start and end point, that is 3 2 4 2. Using that we can find out the slope. This is here I want to give the basic idea of our DDA algorithm. So what actually we are doing, we are finding out that differences we called as a dx and dy. So dy is y2 minus y1 and dx is x2 minus x1. Now under DDA algorithm we have to first check the which value is bigger, dx is bigger or dy is bigger, and that bigger value we consider as steps. Okay, so here dy is bigger, so steps will be 5. Apart from this, we have to find out the incrementing factor of the original values. See, when I plot the point 3 2, next time I have to change the value of x coordinate and I have to change the value of y coordinate to plot the second point. Then again I have to change the values and I have to plot the third point. So this new values how I will get is using this incrementing factor. So that incrementing factor we can consider as dy upon length, that is the steps. So here dy upon length, so that is, first we will see for dx. So dx upon length, so dx is 1 and length, that is number of steps which we have find out are 5. So here my incrementing factor will be 0.2, and in the second case dy, it is incrementing factor is 1. So what actually it means, first I will plot the initial point, that is 3 2. Then what I will do, I will change the value of the first coordinate, that is 3. I am going to add dx. So in 3 I am going to add 0.2, and in 2 I am going to add 1. So my new values will be 3.2 and 3. Then again I am going to add the next point. So again I am going to add 0.2 and 1 in my original values. How I'm getting that original that incrementing values, whatever difference, that is dx, I am going to divide it by total number of steps. So that length is actually steps. So steps I find out which one is the bigger. So my dy is bigger, so steps are 5. So I am going to divide dx with 5, that is my incrementing factor for the x coordinate, and I am going to divide dy by 5, that is the incrementing factor for y coordinates. Now let's see the same thing with the example. See here you can easily see it is the same example. It is the same, this one example. If you check, the start point is 3 2 and the end point is 4 7. So my x1 is 3 and y1 is 2, x2 is 4 and y2 is 7. So start point is 3 2 and end point is 4 7. Okay. So number of steps, that S is number of steps. So how I'm going to find out the steps? I have to check first, y2 minus y1 is 5, x2 minus x1 is 4 minus 3, that is 1. What is bigger in 5 and 1 is 5. So that's the reason I have to consider steps as 5. In DDA algorithm, what is the first step? We have to calculate this difference of x coordinates and y coordinates. Which one will be the bigger? That is your number of steps. So in this case, the step is 5. Now I have to find out the incrementing factor. So I am going to find out the incrementing factor. This difference, whatever difference will come with x and y, that I have to divide by number of steps. So first is x2 minus x1, that is 4 minus 3, that is 1. That difference I am going to divide by 5 number of steps. So what I am getting? 0.2. And second, y2 minus y1, that is 5. That again I am dividing by number of steps, that is 5 divided by 5, I am getting 1. So here I got steps as well as my incrementing factor. I am representing them as dx and dy. So 0.2 and 1. Now I start with this is how many times I am going to plot the points. So these steps only the number of times I have to plot the different points. So initial point will be 3, 2. Initial point will be 3, 2. Next point will be, see this incrementing factor, that is 0.2 and 1, that I have to add in the original x and y values. So my initial value are 3 and 2. Start point is 3 and 2. I am going to add 0.2 in 3 and 1 in 2. So I get new values 3.5 and that is 3. So initially I approximate it and the plotting point is 3, 2. Now I am going for the second iteration. See over here. So this point I plot 3, 2. That point is shown with the blue color. You can check. Now I am going for the second step. So here again the same thing is happening. So I added 0.2 and in this case I added 1 in that. Okay. So x, in the original x I added 0.2. So my new value is 3.7. And in the original y, that is 2.5, I added 1, so it becomes 3.5. The result is actually the point which I have to plot is 3.7, 3.5. Now I have to do the approximation. So approximately it is 3, 3. So you can check in the graph, the second point is plot 3, 3. Okay. Now the next iteration again. Here again in x I am going to add 0.2 and in y I am going to add 1. So the new values will be 3.9 and 4.5. Actually I have to plot 3.9, 4.5, but since 3.9 it's not possible to plot, we are going to approximate the thing. So the new points will be 3 and 4. So this point is also plot. Then the next iteration, 0.2 and 1 added, new values 4.1, 5.5, the point is 4, 5. So that point is plot now. After that, see next step, again 0.2 and 1. This way 1 point will get plotted since our number of steps 5. So after 5th step we have to stop. This is done. So 4th step is over and this is my 5th step. So if you check, the final plot point is 4.7. So I reach up to the end point and this is how the line will get generated. 1 point get plot and the line get generated. So we understand what is mean by line, we understand what is mean by segment, and what is slope and what is y intercept of that line, that is the line equation, y is equal to mx plus c. We understand that using that equation we can plot the points. What logic we are going to apply over here? We are going to find out the x differences and y differences. We will compare thing which one is the bigger, that we will use as steps, and plotting the points we need some increment values. So how we are going to find out that increment values? So whatever is difference in x divided by number of steps, what is the difference in y divided by number of steps. Once we got all these things, then we have to repeat the loop till the number of steps and we will get the final result. Now over here we will actually discuss about DDA algorithm. The digital differential analyzer DDA algorithm is an incremental scan conversion method. So as I discussed, we should have that start point and the end point. Okay, so what is that? We will find out the difference, that is dx and dy. Then we will compare which one is the bigger. This is now I am representing as a algorithm. So I compare dx and dy, which one is bigger, that will be my number of steps. Then second, I have to find out the increment values for x coordinates and y coordinates. So x increment is whatever difference is there dx divided by number of steps, and whatever difference is there dy divided by number of steps. There are one more factor, that this is the thing dx x2. So I will get the incrementing factors also. Actually there are three cases. Your slope sometimes will be more than 1, sometimes it will be less than 1, and sometimes it is equal to 1. Based on that your incrementing factor changes. Okay, so if it is less than 1, then there is no change in the y values. If it is equal to 1, then both values will change, x will also change, y will be also change. And if it is smaller than 1, then your x values will not change, it remain constant, but y values changes. Okay, by default the things comes when you calculate the things, now by default it happens, but you can remember with this three things, that your slope is either 1 or it will be more than 1 or less than 1, and based on that your incrementing factor changes. So if it is equal to 1 now, then both x will also change and y will also change. But in the first and the last case, either x will come 0 or y will come 0. Okay, so only one values will change, other value will not change. This is the program, this is a C++ program for DDA line drawing algorithm. These programs are easily available on the net. If you check, the initial values are taken, that is start point and end points are taken, then the difference is calculated. Okay, then if loop is used to decide the steps. Once the steps are decided, then incrementing factors are found. Initialization is done for x and y. First x and y are plot. Okay, then x and y values are changed with the help of the incrementing factor. Okay, then if you check, there is a delay of 100 seconds. So after plotting every point there is some delay and the next point will be plot, and step by step you will get the complete line. What are the limitations of DDA algorithm? The rounding operation and floating point arithmetic are time consuming procedure. See, we directly don't get the complete values, we get the float values, right, with values with the decimal points. So these calculations will take time, and rounding of error can cause the calculated pixel position to drift away from the true line path for long line segments. See, when the line segments are very long, that time this approximation may go wrong. Means sometimes the point will be get placed at some location which is little far, and you get a crooked line. Crooked line means zigzag type of line. Okay, there are more chances. These are the limitations of DDA algorithm, and that's the reason we use some other algorithms, that is Bresnan's line drawing algorithm, which gives a more smoother line. So to overcome these limitations, we use Bresnan line drawing algorithm. In today's session, we actually try to cover what is a line, what is a segment, line equation, we try to understand. And then when we are plotting the points or when we are drawing the lines, how we are using this DDA algorithm, that we understand. So in short, if I want to tell you now, it's very easy. First thing, you should have the start point and end point. You have to find out the differences, x difference and y difference. Okay, once you got both the differences, then you check which one is the bigger, that is your number of steps. After steps, you have to decide with what values your x values and y values will change. So x values will change with a factor. How we are going to calculate that factor? That is the x difference divided by number of steps. And how we are going to calculate the y factor? That is y difference divided by number of steps. Once the steps are decided, now this many times your loop will reoccur, so that your points will get plotted. So here we come to the end of DDA algorithm. Thank you everyone.